In this tutorial, we are going to talk about Pythagorean identities and simplifying trig expressions. So over here, I have the first quadrant of the unit circle. So because it's a unit circle, I know the distance from this point over to this point would be 1 unit. And because this is the point xy, the side here of this triangle would be x units long, and then this leg over here would be y units long. So if you wanted to use the Pythagorean theorem to write an equation based on this right triangle, we would be able to say that x squared plus y squared equals 1, or 1 squared, which simplifies to 1. So how could we use this and substitute in our trig functions? Well, we know that for a terminal point on the unit circle, the x-coordinate of the terminal point is actually the cosine of your angle. In this case, our angle is t. And then the y-coordinate is the sine of that angle. So what this tells us then is that we could replace x with cosine of t and y with sine of t. So x squared is going to be cosine squared of our angle, plus y squared is sine squared of our angle equals 1. And notice it's important that you're squaring the trig function, you're not squaring the angle. So the 2 doesn't go over here after the t. This is what we call our first Pythagorean identity. There are actually 3 of them, but what's nice is that this one, if you memorize it, you're able to derive the other 2. So let me show you how we come up with those. So if I rewrite what we just found, cosine squared of t plus sine squared of t equals 1. I'm going to write that again one more time. Cosine squared of t plus sine squared of t equals 1. Both of these trig functions we're going to utilize to derive the second and third Pythagorean identities. So we have cosine squared and sine squared. You need to pick one of them, and you're going to divide everything on both sides by that one trig function. So if I divide everything on both sides by cosine squared of t, then cosine squared divided by cosine squared is 1, plus sine squared divided by cosine squared is equivalent to tangent squared of our angle, equals 1 divided by cosine squared is secant squared. So 1 plus tangent squared equals secant squared. This is our second Pythagorean identity. Over here now, instead of dividing by cosine squared, I'm going to divide everything on both sides by sine squared. Cosine squared divided by sine squared is cotangent squared of our angle, plus sine squared over sine squared is 1, equals 1 over sine squared is cosecant squared. So we have all 3 of our Pythagorean identities. On your paper, I have a box there for you to write all of them. Again, as long as you remember that first one is cosine squared of your angle plus sine squared of your angle equals 1. If you memorize this one in your head, you can derive the others. So if I were to divide everything by cosine squared, we would have 1 plus tangent squared equals secant squared. And if I divided everything by sine squared here, we would have cotangent squared of our angle plus 1 equals cosecant squared. So these are our 3 Pythagorean identities. One thing to keep in mind is that these identities could be manipulated. In other words, you could solve for different pieces. So for instance, from the first one, maybe I wanted to isolate sine squared. So sine squared, if I took away cosine squared, that would equal 1 minus cosine squared of your angle. So this stems from the original Pythagorean identity, but I just wanted to show you that you can change things and solve for different pieces. So for instance, if you wanted to solve for cotangent squared, you would take away 1 on both sides. Whoops, instead of writing an equal sign. We could say, for instance, that cotangent squared is the same thing as cosecant squared of our angle minus 1 if we took that 1 away. So there's lots of ways to rewrite each of these, but as long as you have those, you're able to continue on into what we're doing next, which is actually simplifying some expressions. So the challenging part about this is you have to figure out where to start the problem. And it's not always going to be the same first step. So in this particular problem, I have sine cubed of x plus sine x cosine squared of x. So whatever comes to mind, I want you to try it. So for me, what comes to mind is I can see that in this particular term, we have a sine of x, and over here in this term, we have a sine of x, right? An addition sign or a subtraction sign is what splits up your terms. So since they each have a sine of x, I could factor out a sine of x. And in the parentheses, we would have sine squared of x plus, if I factored sine of x out of here, cosine squared of x. And you might be thinking, well, that doesn't look any better. But think about what we just found out on the front of your worksheet. This right here, sine squared of x plus cosine squared of x, is one of your Pythagorean identities, right? If we add sine squared and cosine squared, we get 1, which means inside the parentheses here is just 1. So it's really the sine of x times 1, which simplifies to the sine of x. The key when you're choosing what to do, you just have to make sure that you're not changing the value of the expression. So multiplying by 1 doesn't change the value. Factoring something out doesn't change the value. But for instance, on this problem, you wouldn't be able to just divide by the sine of x, because then you're changing the value of the expression. Number 2, secant of x plus 1 times the quantity secant of x minus 1 divided by sine squared of x. So for me, what stands out is I have two binomials multiplied together. So I'm going to FOIL these. I'm going to multiply them together. So the secant of x times the secant of x is the secant squared of x. Secant of x times -1 is minus secant of x. 1 times positive secant of x is plus the secant of x. And 1 times -1 is -1. All of this is over sine squared of x. A negative secant and a positive secant are going to simplify to 0. So in the numerator, we really have the secant squared of x minus 1 over sine squared of x. As soon as I see a trig function that's been squared and a 1 together in an expression, I'm thinking to myself, is it possible that this is a Pythagorean identity? So secant squared of x minus 1. Let's look back. This expression here, this equation, this identity has a secant squared and a 1. So let's see if we take away 1 from both sides to get secant squared of t, in this case, minus 1, that actually equals tangent squared. So that means that I can simplify this, and I could say that the numerator is actually tangent squared of, in this case, x over sine squared. The last thing we want to do is simplify this. I know that tangent squared is equal to the sine squared of x divided by the cosine squared of x. And then we're taking that and dividing it by sine squared of x. Dividing by the sine of x, or the sine squared of x, is the same thing as taking this and multiplying by 1 over the sine squared of x, right? Dividing by 4 is the same thing as multiplying by 1/4. So dividing by sine squared is the same thing as multiplying by 1 over sine squared. So sine squared over sine squared is 1, which means we would get 1 over cosine squared. And finally, we could say that that is equal to secant squared. Many of these simplified problems are going to simplify down to a single trig function or sometimes just a number. Again, simplify. And again, I see a binomial times a binomial. So for me, what I'm planning on doing is FOILing it out again. So we would have the secant of y, 1 times negative tangent, that's minus the tangent of y, sine y times secant y, so plus sine y secant y, and then sine y times negative tangent y, so minus sine y tangent y. Order of operations says we multiply before we add or subtract. So I'm going to go ahead and I'm going to simplify each of these. So the sine times secant, remember the sine of y times secant is the same thing as the sine of y times 1 over the cosine of y, which means we actually get sine of y over cosine of y, which is the tangent of y. So it's like adding tangent of y to what we had over here, the secant of y minus the tangent of y plus the tangent of y, and then minus over here to simplify this, we have the sine times sine over cosine. So multiplying across, we would get sine squared of y over the cosine of y. So I can see here that we actually have a positive and a negative tangent. So those would simplify. And then I'm going to go ahead, just so that I have, instead of having 3 different trig functions, I'm going to rewrite secant of y as 1 over the cosine of y minus sine squared over cosine of y. And that's beneficial because now these are 2 fractions with the same denominator, so I can subtract them. So we would have 1 minus sine squared of y over the cosine of y. And this, again, is a Pythagorean identity. 1 minus sine squared is, if I take sine squared away from both sides, 1 minus sine squared of our angle is cosine squared of your angle. So that means this numerator, 1 minus sine squared, is actually cosine squared over cosine. Cosine squared over cosine simplifies to just cosine. There are many ways to do many of these problems. So just because I do it one way doesn't mean that mine is the only correct way. There's many ways to do these. For example, on this problem, you might notice that 1 plus the tangent squared of theta is actually equal to secant squared of theta because that's a Pythagorean identity. So we would take cosine squared of theta times secant squared, which we know cosine squared times secant squared is the same thing as 1 over cosine squared. So multiplying across, you get cosine squared over cosine squared, which is 1. That's one way to do this problem. Another way, you could take cosine squared of theta and distribute it times 1 to get cosine squared of theta. Cosine squared of theta times tangent squared. Tangent squared we know is sine squared over cosine squared. So if I were to multiply that by cosine squared of theta, cosine squared over cosine squared is 1. So this is really cosine squared of theta from here plus sine squared of theta, which again is an identity, and it is equal to 1.